Hey, I'm Dylan. I'm an iOS developer at Door to Door. We work on apps for mobility, transportation, and basically for getting users from A to B. So today I'm going to give an overview of unit and UI testing on the iOS team and how it's improved over the last couple of years, some of the tools we've been using, some of the approaches we've been taking, and we'll dive into a bit of code as well. So we'll start with unit tests. So why were we not writing many tests a couple of years ago? This is very opinionated, but I would say that Apple's test suite offers poor and outdated syntax. They're difficult to write, these tests. They take a long time to write. They're not very readable, and it's an all-around bad developer experience that we get with the default toolset that Apple gives us. It's not enjoyable to write these tests, I would say, and I think that was part of why we weren't writing them. There's a lot of tooling that isn't available, such as, how do we mock things? For example, there's a lot of manual effort required there. So we were not investing as heavily as maybe we should have been in testing. So this is a kind of rough overview of our architecture that we use within our project. MVP Plus is kind of how I'd refer to it. It's a model view presenter, but with some other bits stuck on top. But these are the important components to take note of. So we have all our business logic separate, isolated in our presenters, and then the presenters will communicate with views, so view controllers, and then sometimes other delegates to inform them about things that are going on within the presenter. And then the presenter will have dependencies injected for networking, for example, or like a user manager. So is the user logged in or out? Details about the user, and for any other kind of communication with backend or with other data sources. So we want to make sure that all our business logic is kept within the presenter, and that's partly so that it's testable, so that when we're writing tests, we're only testing logic. We don't want to be testing views and how they behave. We don't want to be performing real networking requests to the backend. We don't want to be getting involved with storing data or retrieving data from databases, core data, user defaults, whatever it is. We just want to focus on testing that logic. So part of how we do this is by mocking everything outside the presenter. And that's where we basically want to create fake instances of real classes, and we want to stub their functions. So that means that when functions on those mocked classes being called, real functionality is not being executed. We're replacing that with fake data or even not doing anything. And that's so we can control the input and output for the presenter and reproduce input and output the same every time we run our tests, so that, again, we're only focusing on testing the business logic and not anything external. So unfortunately, mocking is a lot of effort if you're just using Apple's tools. If you're just building your mocks from scratch, you have to go through a lot of effort to manually recreate classes to make kind of fake versions of them you can then inject as dependencies or set as properties on the presenter, such as a mock view or a mock delegate. So to achieve this, we ended up using a couple of libraries we found and I'm very happy with. So the first two are Quick and Nimble. These two libraries work very closely together. So Quick offers syntax to make very readable tests. It's based on RSpec, which is a popular Ruby library for writing tests. And we'll look at some examples of that a bit later. And Nimble offers readable and feature-rich assertions, making it easy to say, for example, I expect this property to have this value. And again, we'll look at examples of this later. And then we have Cuckoo, which is a great library which allows you to very easily mock dependencies or whatever classes you like. And it does this by subclassing protocols or classes, and will automatically generate mocks of your classes by doing that. And once that's done, you can then verify that these stubbed functions on these mocks are called. So you can verify that your presenter or whatever class you're testing is calling the functions on your mocks. So here's an example of Quick and Nimble. So this is one test where we were testing a mapper and that it's mapping one model to another. So you say we have this nice syntax: describe route to header view model map test, context when the route is walking route. Nice human readable syntax, and that's very much based on RSpec. And then we have some further context when the departure is in less than 15 minutes. And then inside we can have multiple its, which is where we have the test itself. So we're saying, first of all, it returns a route type string for walking. So we're saying that we expect that the model's route type should equal the string walk. And you can see here how nice and easy to read that is. And there are a lot of different matches you could use. So to equal is just one example of what you could do. You could say to not equal, to be nil. You can even do to eventually be. So your test will actually wait a little bit for a value to be true, for something to be equal to a value. So there's a lot of combinations you can use, and you can just dive into the README and get a lot more information there. So onto Cuckoo for mocking our dependencies and stubbing the functions on these mocks. So before suite is where we can put all of our setup for all the tests we want to add below this. So here you can see we're setting up a few mocks. So for example, the first one, configuration holder equals mock configuration holding. So configuration holding is a protocol to which configuration holder conforms. And then we just put mock before that. And at compile time, Cuckoo will create a mock. So it creates a mock of configuration holding and sticks the word mock in front of it. And that's all you need to do to get access to that mock. And then you see we do the same for delegate interactor and view. They're all mocks of protocols. Then we create our planner presenter, and this is a real implementation of planner presenter, not a mock, but we're injecting a mock configuration holder into that as a dependency. And then we're setting delegate interactor and view as mock properties. And then we can stub, for example, our view. That's a mock, so we can stub functions on it, and we can say how these kind of fake functions should behave. So for example, we're saying whenever set polygons is called on the view with any, so with anything being passed into that function, then do nothing. If you look at the last example, expand time bubble, we're saying that whenever expand time bubble is called with the search mode text that is any string, and the date text that is any string, and animated that is any bool, doesn't matter if it's true or false, we're just saying if it's a Boolean, then if that is the case, then do nothing. And there's more you can do than do nothing. You can say, for example, then call real implementation if you want to actually call the real functionality of that function. Or you could do then return. If it's a non-void function, if it actually returns a value, you can say then return this or that. So by using Cuckoo's verify statements, we can check that our stubbed functions on our mocks are being called when we expect them to. So here, for example, we're saying with the context when the time bubble should be expanded, when the selected search mode is arrival, and when the selected date is in the next week. Then before you run any test, we want to do a bit of setup. So we're just creating a couple of dates and then calling planner presenter's expand time bubble function. And then we want to check with our it test that expand time bubble is being called on view, but not just that, but that's being called with the parameters we expect. So we expect the search mode text string to be arrive, the date text to be Wednesday at midnight, and that we're saying animated is true. So a few of my top tips for writing unit tests: separate and test only your business logic. That's all you want to be focused on. Get rid of the view. Don't worry about testing, real backend communication or talking to a database or anything. You just want to be testing that your logic makes sense. Force unwrap. I would say don't worry about null safety in tests. Don't worry about unwrapping properly. Just put exclamation marks everywhere. It's fine. Because if there's a problem there, your tests will fail. It's only going to fail on your local machine or on your CI, and then you can go fix it. It's not a big deal. And let your tests influence your dependency structure. So what I mean by that is, for example, is let tests show you where you can separate your concerns better. So for example, if you're doing a networking call directly in your presenter or whatever your class is that's taking care of your business logic, and then you're running tests on that, you're going to find that you're performing a network call every time you run your unit tests, which you don't want. And that will show you that you should separate that into a different class and have it as a dependency instead, and a dependency that you can mark. So let your tests show you how you can clean up your code and better separate the components in your code base. Okay, so now let's move on to UI tests. So the original problem we had was that while we were now doing more unit testing and we were testing on business logic, and that's great, we didn't have any automated methods still of testing that our core flows going through the app work as we expect from end to end. So a real user journey, can they log in or register? Can they then perform a search for how they can get from A to B? Can they then book a ride? Does this all work from start to finish? And for this, we were relying just on manual testing. So we'll go through the core flow of the app before each release. Every couple of weeks, before we released an update to the app, we would be manually testing that the core functionality still works as we expect it to. So we looked at a couple of libraries for this. One pretty big one is from Google called Earl Grey, and that's their solution for UI testing. We tried to make it work quite a bit, and to be honest, it could be better these days. Maybe we were misunderstanding something, but we couldn't get it to work reliably. A little bit, yes, but in a very flaky way that felt like it could just fall apart the next time something's updated. It wasn't reliable. It was very complex to set up and maintain. So in the end, we actually stuck with XC-Test. So we stuck with Apple's own UI testing library, which I've got to say is actually pretty good. It's reliable and it's pretty easy to write these UI tests. So we just stuck with Apple's default tooling, unlike with unit tests. So there are some big benefits that writing UI tests gives you. For example, you can automate going through core flows in your app, and that's one of the main reasons we want to do it. We thought we could save a lot of developers' time by automating testing these core flows from end to end. On top of that, during developing new features, we thought it'd be helpful to check that the UX behaves as expected, that the app continues to behave as we expect. When you tap this button, does it still go to this screen? When this happens, will the screen be dismissed? Just checking that all that is still always working. There are some big downsides to UI testing, though. It's sometimes pretty flaky. So UI tests will quite often just fail for no particular obvious reason, and then you just run the test again and it's fine. And running all these UI tests is pretty slow because you're actually launching the app, you're mimicking user tapping buttons, swiping, scrolling, zooming in and out. So this kind of real-time app use speed. So a single UI test can take, most files take 1 or 2 minutes to run. So while UI tests are always going to be slow and they're always going to be a bit flaky, we did find there was one thing we could do to help with some of that flakiness and speed up the tests a bit, which is to bring in an new library called Succulent. It's quite underrated, not so popular Swift library, but it's very useful because it records and replays network requests for you as you run your UI tests. And this helps to remove some of the flakiness of UI tests because you're not performing real requests every time you run the UI tests, only the first time you run them. So it'll spin up a local server on your machine, your local machine, or on your CI machine, and will record the network requests and responses that the app's making on the first run, saves that into a trace file, and then on future runs of that UI test, it will get the responses to your requests from that trace file through this local server instead of going to your real backend. So let's jump into a demo now of our registration flow UI test, and then we'll look at the code behind it afterwards. So let's start with how we set up all of our UI tests in our setup function. First, we create our XUI application, and then we start setting up succulents. So first, we check for a trace URL. So we're checking if there's already a trace file that's been recorded for a particular UI test. So we're checking if requests and responses have already been stored for a UI test that you've already run. And if that's true, then we configure succulent with that trace URL so that it knows to not record real requests again, but just access the trace file to get us our responses. Otherwise, we set up succulent to record new requests and responses to our record URL, which is the URL where the trace file will be stored. And we also give it a base URL. So we give it the real URL, which succulent should perform requests to, because it's acting as an intermediary, as a local server on your own machine, on your CI machine. So we can start succulent, and then before we launch the app, we set a launch argument UI testing. And this is so that in your code base, you can do a check for a launch argument, and we can check if UI testing exists as a launch argument. Then we do certain setup for UI tests, but this should be minimal. You shouldn't be interfering too much in your actual code base because you want to be testing, the real flow. You don't want to be mocking too much. But if you have to do some additional setup, which we do, then you can do that. And then we set the launch environment succulent base URL to the URL of the local succulent server, which is localhost, and then the port that succulent gives us. So here's where we need our UI testing launch argument. It's so that we can reset the state of our app each time. So we set the user to nil to effectively log the user out, and we set skip login to false so that the login process is not skipped. And when we run our UI tests, we need to go through the login or registration flow. So basically, this is just something we need to do to kind of reset the app each time we run it. And then we need the succulent base URL to tell our networking setup to use the succulent URL instead of our real backend URL. Because now when we run our UI tests, of course, we want all of our requests and responses to go through succulent so it can record or replay them. But only in the case that we're running our UI tests. Otherwise, when we run the app as normal, it will use our real backend URL. So this is an extra function we wrote for asserting that a certain element exists on screen as we expect. So we already have this wait for existence function, which you can call on any element, and you always have to pass a timeout. So you say, wait this many seconds to check that this element will exist on screen. We decided that it was a bit annoying writing usually the same timeout of 3 seconds every time we want to check that element exists. So we wrote this wrapper function with a default timeout of 3 seconds so that we can just call our assert exists function, pass in the elements we want to check the existence of, and then by default, that has a 3-second timeout, or we can pass in a different timeout if we expect it's going to take longer for something to appear on screen. And then this is the example of the whole of our registration flow test. It's mostly a lot of tapping on fields, typing text, and checking that elements exist. So you can see we start with checking that A button with a particular ID can be tapped, and we tap it. And then we do the same for a few text fields. We tap them and then type in some strings. We do the same with the secure text fields, so the password field. And then we're tapping some more buttons and just checking the elements that we expect to exist do, until eventually the whole registration flow has been gone through, and then we can open the menu and check that the user's been successfully logged in, ending with an XC assert true to check that the menu shows the logged in as string at the top. The easiest way to access specific elements is by giving them an accessibility identifier in your actual production codebase, and then that's the easiest way to refer to them in UI tests. And just add that as well as .tap, you can swipe, you can zoom, you can do all sorts of gestures and interactions on your elements. So a few top tips: test only your core flows. Don't try and test every feature of your app. Test every single possible user journey. Just test the core flow of your app that you really can't have break every time you want to do release. The most important functionality should always work. Reset any cache data. Start with a clean base every time you want to run a UI test. So anything to do with being logged in or some state that was set when you've been running other tests, reset that every time. Avoid doing real network requests where possible. Of course, I'd recommend using Succulent. It's a great tool for that. But however you want to do it, try not to perform too many or any real requests to your backend. It'll only slow down your tests and it makes them less reliable. And then consider not running your tests on your CI on every single commit. Because they take so long to run, you might only want to do them, for example, when you merge into your master branch or before release, or maybe you want to do a nightly build to run your tests. But as you write more and more UI tests, it takes longer to run them all. You might not want to be running them every time you commit to a PR. So here are a bunch of links. If you want to check out the libraries I mentioned, Quick, Nimble, Cuckoo, or Succulent, here are the links. They're all worth checking out. I've written a couple of articles on units and UI tests on Medium, so you can check those out if you want. And you can ask me questions. I think you'll be able to now, but if you want to do that after the meetup as well, then you can always tweet me. And that's it. Thanks for listening.